In our lesson of probability, we will determine whether events are independent or dependent and find the probability of independent and dependent events in our channel, Rose Math Labs. Let's recall with an example. Read the question carefully and check your answers. So out of 12 beads, probability of choosing a blue bead at random will be 5/12. Choosing a green bead at random will be 2/12, and this in the simplest form 1/6. Choosing a blue or a yellow bead, so blue are 5 and 1 yellow, that is 6/12, in the simplest form will be half, and so on. Hope you have got the concept. Do not forget to subscribe my YouTube channel Rose Math Labs to get access to practice questions and answers. So the keywords in our lesson independent and dependent events will be independent events, dependent events, and conditional probability. Let us understand what it means. Events are independent if the occurrence of one event does not affect the probability of the other. Let's see this example of independent events by a simple example of tossing a coin. We know it's a fair coin having two sides, heads and tails. We will toss the coin twice and check their probabilities. After the first toss, the outcome can be either head or a tail. And we know since it's a fair coin, the chances being a head and tail are equal. The probability for each being half. Now once we have got head, we flip the coin the second time. When we flip the coin the second time, again the chances can be either head or tail. So the occurrence of the head during the first toss will not affect the second time. Hence it's an independent event. And here again the outcome will be half and half. Remember, the coin, when we flip it the second time, does not have any memory of the first toss. Similarly, when we got the first toss as a tail and we toss it the second time, again the chances can be either head or tail. And the probability for coin will always be the same, that is half and half. So the possible outcomes can be head and head after the two tosses, or it can be head and tail. That means in the first toss a head, the second toss a tail. Or it could be in the first toss the tail and the second toss a head. Or it could be both tails. Now to find probability for each outcome, we can see this tree diagram here. We need to multiply the probability on each of the branches. So to get the probability head twice, the outcome probability will be half into half, that is 1/4. Similarly, to get a head and a tail, we need to multiply the probability on the branches, that is half into half. So the outcome for head and tail is also 1/4. The outcome for tail and head, when we multiply the probabilities, we get 1/4. Tail and tail, again half into half, 1/4. When we add the four probabilities, the four outcomes, it will always give us 1. Hence we can say that if A and B are independent events, then probability of A and B will be the product of the two probabilities. So they are independent events if the occurrence of one event does not affect the probability of the other one. We just saw the example of tossing a coin. So to get head twice, the answer will be 1/4. The probability of the outcome getting head twice will be half into half, 1/4. Now let us see dependent events. Events are dependent if the occurrence of one event affects the probability of the other. For example, suppose there are 2 apples and 1 orange in a big bag. You pull out 2 pieces of fruit. The probabilities change depending on the outcome of the first. Let us see that example in detail. The tree diagram shows the probability for choosing 2 pieces of fruit from a bag containing 2 apples and 1 orange. So here is a bag and we choose a fruit randomly. The probability of choosing an apple or an orange randomly will be 2 out of 3 and 1 out of 3 respectively. Since we know there are 3 fruit in all and 2 are apple, so 2 out of 3. But there is only 1 orange out of 3 fruits, so 1 out of 3. Now the first event has already occurred. Again we choose a fruit randomly. In the first case, where we have already chosen an apple, now we are left with only 2 fruits, 1 apple and 1 orange. So let us again randomly choose an apple and an orange. So the chance of choosing an apple will be half, since 1 apple out of 2 fruit. And the chance of choosing an orange will also be half, since 1 orange out of 2 fruit. So the probability for each will be half and half. Hence you see the occurrence of the first event has altered or affects the occurrence of the second event. Hence it's a dependent event. Now let us see the second case. In the second case, we have chosen an orange at random. So here again, we are left with 2 fruit. But here the orange is gone, so we are left with both apples. Let us now check the probabilities of choosing an apple and an orange randomly. Now to choose an apple randomly, the chance will be 1 whole, since we are having 2 apples and we are choosing an apple. So 2 out of 2, that is 1 whole. For choosing an orange, we do not have any orange. So 0 out of 2. Hence the probability of choosing an orange will be 0. So the occurrence of the first event affects the probability of the second event. Hence this is an example of dependent event. The probability of specific event can be found by multiplying the probabilities on the branches that make the event. For example, now if I need to calculate the probability of the outcome both being apples, so we multiply the probability on the branches. So we multiply 2 over 3 by 1 over 3 by 1 over 2. So we get the answer as 1 over 3 in the simplest form, because it will be 2 over 6, that is 1 over 3. Hence we can summarize that if A and B are dependent events, then probability of A and B will be probability of A into probability of B given that A has occurred.